There we go. Okay. Um, so yeah, any questions or anything we need to talk about from last week? Okay. You guys are good. I'm good. We know how to do substitution and elimination stuff, then nothing really stops us from doing it with bigger systems. And the kind of idea basically is that you can solve for as many unknown things as you have equations, because each equation is like a piece of information about how the things relate. So what we're going to look at today is solving 3x3 systems, which means 3 equations in 3 unknowns. So these are going to be in terms of x, y, and z. I will, just put out kind of a blanket warning, like make sure that your z's don't turn into 2's at some point, because like we're going to do a bunch of stuff, right? And I've seen people do that before, that they just sort of gradually turn into 2's, and then all of a sudden you're like doing different things. So just watch out for that. Yeah, so because these are in terms of 3 unknowns, if I want to think of it in like graphical terms, what that means is that this isn't a thing that lives in the plane anymore in 2-dimensional space, because there are 3 variables. It's a thing that lives in 3-dimensional space. So these are all linear. Notice everything's to the first power. That means they're lines, but they're lines in 3 space. That means you've got planes. So what we're talking about is 3 planes instead of 2 lines that live in the board or in a screen. We're talking about 3 planes that live in the room, right? So I mean, really what I'm driving at is like we're still talking about the same thing. We want to find intersections, but I can't really graph those in a way that's going to help, right? So we kind of lose that a little bit, because even if you graph 3 planes in 3 dimensions and look at it on a 2-dimensional screen, it's weird and kind of hard to read. It's like the idea is the same, but we can't really approach it in exactly the same way, at least not as a way to solve. So that's the bad news. The good news is that all of the other stuff that we know how to do still works. We're still going to use substitution and elimination. We're just going to do more of it, basically. So kind of our goal is that, let's make a plan. Use substitution, elimination, either, both, whatever, to reduce this the 3x3 system to a 2x2 system, then solve, and then just kind of work our way back up, right? So if you remember the stuff we looked at last week, we did substitution or elimination. We solved, we got like x equals 5. Then we just kind of backed up and said, okay, well, if x is 5, then here's what y would need to be to go with that to solve the actual system. We're going to do kind of a similar thing here. It's just going to be kind of a multi-step thing, right? So we're going to take these 3 equations and 3 unknowns. We're going to use substitution and elimination to combine them, right? And kind of mush all 3 of these equations together so that we get a thing that's got 2 and 2 unknowns. Well, we know how to solve that. So we solve that, and then we get, z equals 3 or something. Then we just kind of start working our way back up. If z is 3, here's what y would be. If z is 3 and y is 1, then x would be 2, right? So once we've got one thing, right? Once I have a numeric value for x or y or z, that's the hard part, right? After that, we just kind of, backtrack and plug back in to find the other stuff that goes with it. Okay. So that's the plan. I want to make sure I got plenty of room here. The one thing that I would advise going into this is to, last week I kind of made a big deal about being deliberate about saying like what my intentions are, right? Like I'm gonna take these two things and eliminate X so that I can solve for Y. That's probably even a little bit more important here, because if what I'm gonna do is take these three things and combine them into two equations and two unknowns, I need those two things to be the same, right? So looking at this and thinking substitution and elimination stuff, what do you see? Give me like two equations that we can combine somehow so that something's going to drop out. The top and the bottom. The top and the bottom. Okay, the top and the bottom one are both equal to 9. Let's focus on the left-hand side of those. 2x, 3x, plus y, minus y, plus z, plus z. So what do you see there that we could use to get something to go away? Either x or y or z. Top and the bottom to get rid of y. Don't even worry about this guy right now. Does everybody see that? Plus y and minus y. So what happens if we add those two equations together? Plus y minus y, that's 0, y drops out, right? Okay, so that's what I'm going to focus on first. Now, again, I'm going to be like really careful to be kind of deliberate about like what we're doing. So I'm going to even number or label these somehow. Let's use letters A and B and C, or 1, 2, 3 or something, like just so that I can keep track of what I'm doing. So I'm going to take A and B, and because I've got plus y and minus y, I'm going to add them together. And that's because the thing that we saw that we could do, right? And this is just like, look at it and what do you notice, basically? Is that using this first one and this third one, I can eliminate y. Okay, so I'm going to try to do that. 2x plus y plus z equals 9. And 3x minus y plus z equals 9. And we are going to add. All right, so if you add those together, what do you get? $5x. The y terms zero out, right? Those cancel. That was why we did the thing in the first place. 5x plus 2z equals 18. Okay. Now this is a new equation, right? It's a new thing. I took two of the things we started with, I mushed them together. I got this, which is a new thing that's in terms of what? X and Z. Okay, do we know what X or Z are? No, they're unknowns at this point, right? I don't know what either one is. X and Z, there's two of them. How do I solve for two unknowns? I need two equations in those same things. So what do we need to be able to go, on? What else do we need to find? Another thing like this that's just in terms of X and Z, right? Basically, I need to make this thing look like one of these things from last week, right? I need to make it, because it's in terms of two unknowns, I need two equations, but they got to be the same kind, right? It's also got to be in terms of X and Z. So I'm going to go back to the original system. I'm going to eliminate Y again, but it's got to be with some other combination, right? I can't use the same two. I got to do something else. So look for some other place that you can take two of these and eliminate Y. Say again. B and C, okay. B and C, if we're going to eliminate Y, negative Y and negative Y, so we need to subtract, right? Or if you prefer to do the like multiply 1 by -1 and then add them together, that's fine. But B minus C These are exactly the same, so they would drop out, right? You could use A and C instead, but you can't do the same exact one because that's just gonna, give you like the same information, right? We just have to choose some other combination. So I'm gonna look at these and say, okay, well, to get rid of y there, I would need to subtract. So let's do that. Three x minus y plus z equals 9. We are going to subtract. Okay, when you subtract those, negative y minus negative y turns into negative y plus y. So those zero out, right? Which is, why we picked the thing in the first place. Then just subtract the rest of it. Negative x minus 3x plus z minus, oh, okay, cool. Z minus z is 0. That's good. And 1 minus 9 is negative 8. Okay, so we kind of got lucky here a little bit. What does that tell you? That x is 2. If x is 2, then I can start working my way backwards, right? If x is 2, where should I go? Where should I take that piece of information? What can I find next? Z, right? Because if x is 2, then z is, well, I don't know, like plug in x equals 2 here and find z. Then you have x and z. Once you have x and z, you can find y by going back to any of these three, right? Okay, so x is 2. If x is 2, then 5x plus 2z equals 18. So 10 plus 2z equals 18. So 2z is 8. So z is 4. Oh, okay. Yes. No, I just wrote that wrong. That was a plus c. Sorry. Yeah. Okay. We didn't do any math wrong. I just labeled it wrong. Yeah. Sorry. Thank you. Okay. So if x is 2 and z is 4. Now, at this point, again, assuming that everything is correct and we haven't just goofed something up somewhere. If this is going to be an ordered triple and XYZ, set that solves the system, that means it's going to satisfy all three equations at the same time. So you can take those and plug them into any of these and you're going to get the same thing. So just pick one. If there's one that looks like it's going to be easier to work with, then do that. Here, they all look pretty much the same to me. So 4 plus y plus 4 is 9. Y plus 8 is 9, so y is 1. So our solution, this is an ordered triple. It's an x, a y, and a z, is 2, 1, 4. Okay. Now again, here, what happened, We combined B and C. It happened that Y and Z both dropped out, so we got X directly, right? I don't necessarily expect that to happen. What we're trying to do here is combine two like pairs of the equations in such a way that we get rid of the same thing twice, right? So what I went into this trying to do is eliminate Y, right? And we picked Y just because I saw a lot of stuff where Y kind of lined up in like a nice way, right, for elimination stuff to work. So I went in with the goal of eliminating Y. Now it just so happened that Y and Z both dropped out here, so I got X. What I expect to happen though is that I've got this equation in terms of X and Z. I get another equation in terms of X and Z. Then I take those aside and solve that system, right, to get one of them. So do substitution or elimination again with those to find either X or Z. Then, you know, this part is kind of how the rest of that goes, like back up. Then when I keep saying like backtrack or whatever, that's what I mean here. You know, work your way sort of back up the problem to find the other things. And then once we've got a value for all three of them, you know, we write that as an ordered triple, and that's your solution. Okay, but again, I think, you know, doing this kind of thing, like planning and being deliberate about, you know, what you're trying to do, I think is helpful here. Otherwise, I can't tell you how many times I've, you know, graded an exam problem or something where people do like 3 or 4 different eliminations and like do them all correctly, but one of them is in terms of X and Z, and another one you get an equation that's X and Y, and another one you get an equation that's Y and Z. Like you're doing a lot of work that's all correct, but none of it's going to go anywhere because they're not the same kind of thing, right? You need 2 of the same kind of equation. You know, again, unless you happen to, you know, luck out and things simplify a little more than that, but you need 2 of the same kind of equation to be able to solve and kind of proceed. Okay, does that all make sense? I think, anyway. All right, y'all try number 2. Just take, you know, a few minutes. Y'all give that one a shot. We'll talk about it in a minute. So what did A plus C get rid of? Y. Okay. Since you got rid of Y the first time. Now go back to the original
system and figure out some other way to get rid of y. Usually, and maybe this is just for everybody, like whatever your first step is, a lot of times there's kind of an obvious or like fairly obvious first step if you're thinking like elimination stuff. Whatever you do for that first step, whatever you got rid of, right? So like Miles just said, he looked at the first equation and the third one, right? So A and C if you want, and got rid of y. If that's what you do for the first step, the second step needs to be get rid of y again with some other combination of the equations. It might not be as obvious a thing, right? So you might have to, scale one or both of them, multiply both sides by something to get coefficients to line up, that kind of thing. Usually you get one that, you can do kind of, a little bit cheaper, a little bit easier. But the second one, maybe you have to work a little harder. But the goal is you got to eliminate the same thing twice. All right, what looks like a good first step? A and C to get rid of y. Okay, so A and C, we're going to get rid of y, we're adding because they're opposite. Negative y plus y is 0. Again, that was, why we picked these in the first place. 4x plus negative 2x, 3z plus 4z, and negative 2 plus 14. Okay. Now again, like if you want, you can think of this as, let's call this D, right? Like this is a new thing that we're going to use to, continue on and solve. What that means is that because this is in terms of x and z, we need another thing that's only in terms of x and z. So go back to the original problem and eliminate y again. Again, looking at these three things, the one that we just used, that was the place where it's sort of easiest or most obvious to eliminate y, right? Well, we can do it in other places too. I'm going to take A and B. If I take A and B and try to get rid of y again, what do we need to do? Multiply the first one by 5. So 20x minus 5y plus 15z equals negative 10. Okay, so I'm going to take, that, right, 5 times a, and add that to b. So the equation I just came up with, 20x minus 5y plus 15z equals -10, and 3x plus 5y minus z equals 15. And I mean, as usual here, like you don't have to keep track of stuff the way I keep track of stuff. You don't have to write stuff the way I write stuff, whatever. But I do encourage you to try to figure out some kind of system to help you keep things organized, because otherwise this will just turn into a giant jumble of crap and you can't tell what you're doing, right? Okay, so we're gonna add these together all the way across, 20 and 3. The y terms drop out. 15z plus negative, so plus 14z. And 5. That's another equation just in terms of x and z. That's the second thing that I need to be able to solve for x and z. Let's call that E maybe. And then you're just going to do another smaller system with those two things. Good so far. All right, so we eliminated y. Again, there was one, kind of like obvious place staring at us to eliminate y. We did that. Then we did it again with the less obvious one, right? Where I have to scale to get coefficients to match. But again, it's just elimination stuff. Then we take those two equations, which are in terms of x and z, and now we're going to solve this smaller 2x2 system for x and z, right? So I can kind of forget for a bit where everything else came from and just focus in on that and trying to solve that. So 2x plus 7z equals 12. 23x plus 14z equals 5. What do you see? What do you want to do? Eliminate z. How? Take the first one and multiply by 2 to turn this 7z into 14z. Right? Get those to line up. So 4x, 14z, 24. 23x, 14z, and 5. If we're trying to eliminate z, we would need to subtract. Once you got that, it should all kind of be downhill from there, right? Like that's the hard work, is getting to that point. And a lot of this, I know it feels like a lot because this is the second time you've ever seen it, and the first was 7 minutes ago or something. It feels like a lot. Mostly it's just organization, right? Like you're doing a lot of very simple things. You just need to be really careful about the details. So once you've done a few, I don't think it'll feel like it's all that bad. Like anytime you sit down and do a problem, it's going to take 5 or 10 minutes or something, because just of the quantity of stuff you got to do. But none of that's all that difficult, really, as long as you can kind of keep track of what everything is and where you're trying to go. So if x is -1, what can we find next? Z. Using either of those two equations that I labeled D and E, right? The two that we came up with, we can find Z. So if x is -1, then D becomes 2 times -1 plus 7z equals 12. So 7z is 14. So z is 2. And I'll do a horrible job of organizing things here, but whatever. If x is -1 and z is 2, then any of the original equations, right? And I mean, it's kind of a toss up. It doesn't really matter which one you use. For x minus y plus 3z equals -2. So -4 minus y plus 6. Add 4 would be 2, subtract 6 would be -4. So y is 4. So our solution is the ordered triple -1, 4, 2. Hard to read with the highlighting on there. There you go. Okay. Again, I know that looks like a lot, right? Does anybody have any questions about how we did anything? All right, well, we got about 10 minutes left, so why don't you guys try? I think there's 2 more on the back, and then there's an application problem where you would set the system up first and then try to solve it, or sorry, not try, and then solve it. Yeah, so let's take the time we have left, y'all. Give those a shot, and you might even just do the first couple of steps, like get it to the point where you got x is 3 or something, and then save the rest for later, right? But that decision making about how to get into the problem in the first place, that's usually the part that you're kind of learning a thing, right? If there are terms missing, like I know 3 and 4, there's some weird spacing stuff, treat it like it's 0, right? So that first equation, x plus z equals 4, that means 0 in place of the y term. No, but the solution's gonna look like one, one, one. So like, what you found so far is that they're all the same. But that doesn't mean like, you know, say X is equal to 7, 7 plus 7 is not 4, right? So it's, yeah, right. What you could do with any, so like, as soon as you got to this, right? X equals Y, then this turns into X plus X equals 4. Right, or Y plus Y equals 4. So then you get, okay, that's 2. Well, one of them's 2, the other one's 2. Well, what's the other thing? Okay. Right, so if you take A and C, subtract X minus 0 minus Y. Wait, you're subtracting here, actually, like right out, right? Right out here next to yourself. Copy it. Subtract X minus, well, there's no like terms to combine with X. That's X. Nothing minus Y. So, you take Y away from. Right? Now, to take those two things, work with them to figure out what's in there. Okay. See you later. Guess we're okay? Okay. Okay, so if X and 2Z is 8, and then X and Z is 4, right? So like, you know, use what you have to do in there, and also what you find here. X plus Z is 4. X plus 2Z is 8. Okay, well, take take those aside and figure out what that tells you about X and Z. Yeah, because that's 2 equations in terms of just X and Z, right? That's what you need to do to solve for 2 things. All right, somebody give me a first move here. Okay. Eliminate Z. So to do that, what, A minus C, something like that? If you subtract those, X minus nothing, nothing minus Y, the Z terms cancel out,
and 4 minus 4 is 0.
So what did we get?
An equation that's in terms of X and Y, right? You can go a couple of ways with this. If you look back to the original problem, you've got another equation in terms of just X and Y already, right? The middle one, B, is just in terms of X and Y.
So you can take those aside.
D if you want. B and D would be X plus Y equals 4 and X minus Y equals 0.
You want to solve that system then.
If X minus Y is 0, that means that X is equal to Y. So you can do a substitution there, or you can eliminate. It's kind of lined up nicely to do elimination too.
You have some options. Again, there's not a way to do these. There's not even a right way.
Sometimes there's one way that's maybe more efficient than others, but you know, it's about just using the tools that you have to get through the thing. So, you know, since I've already written those out,
I'm just going to add them together. Excuse me. So the Y drops out. I get 2X is 4, so X is 2. And then we just start working our way back, right?
if X is 2, then Y must be 2 also. If X and Y are both 2, then Z is also 2. So 2, 2, 2 is the
Solution, but I'll let you, work through the details.
Okay. All right. So again, homework for 7.1 is due tonight. This is all there is to 7.2, is just the 3x3 system stuff. There's not really anything else I need to say about it. Tomorrow we'll take a little bit of time to talk about any questions that we need to. I'm going to give you a quiz on 2x2 stuff, so be on the lookout for that. Then we might go ahead and start on the major C stuff and just see if we can knock it out and move on with our lives. Tomorrow night, sorry. Yeah, sorry, tomorrow.